There are lots of explosions that happen here on Earth every day, but all of these pale in comparison to the cosmic explosions known as supernovas. Supernovas are the final stage of a larger star's life cycle, and are among the brightest and most intense events in the universe. How do these cosmic detonations happen? Let's find out! Supernovas are classified into two main categories. The first type is called a thermal runaway supernova. This reaction begins with two normal-sized stars in orbit around each other. As the larger one goes through its life cycle, it becomes a red giant. The outer layers of the star eventually poof off into space, leaving behind a white dwarf made of extremely hot carbon and oxygen. This loss of mass causes the two stars to orbit closer to each other in order to conserve angular momentum. The second star also eventually becomes a red giant, but this time, its proximity to the white dwarf means that large amounts of the giant gets captured by the smaller dwarf star. As it gathers more and more stuff, the white dwarf's temperature rises until it reaches the point where carbon and oxygen can begin fusion. This fusion quickly runs out of control, converting a huge amount of mass into energy in a matter of seconds, causing the star to tear itself apart in a supernova. The second classification is known as a core collapse supernova. As an extremely massive star goes through its life cycle, it develops layers of different gases. Eventually, gravity at the core becomes too strong for nuclear fusion to resist, and the star begins to collapse. As this happens, the intense pressure in the core actually pushes protons and electrons together, releasing high-energy particles known as neutrinos, and it forms a rigid, stable neutron core. The star continues to collapse, but the outer layers bounce off of the rigid neutron core, creating an outward-facing shockwave. This explosion picks up energy and speed, fueled by the neutrinos from the core, until the outer layers of the star are ripped apart in a supernova. In this situation, a neutron star is left behind. However, if the star was even more massive to begin with, the neutron star continues to collapse inwards, forming a singularity, otherwise known as a black hole. These events are extremely violent and energetic, sometimes even being billions of times brighter than our own sun. Effects of these explosions can even be seen here on Earth. In fact, it's hypothesized that one of the major extinctions on Earth was caused by gamma radiation from a faraway supernova interacting with our atmosphere. Thankfully, however, these events occur extremely rarely, and they happen far enough away that they don't affect us significantly. Want to learn more about supernovas? Check out our blog in the link just down there. If you have any questions, you can leave a comment or like or subscribe to our page.